Hello everyone, welcome back to my channel. In today's video, we are going to be talking about calculating resistance in a parallel circuit. Uh, we're not going to deal much with calculating resistance in a series circuit because that might be a little bit simple, but we're going to focus on how we can calculate resistance in a parallel circuit. Just to go through, in a series circuit, this can be an example of resistors in a series circuit. Now, you might see this resistor, the 3 ohm resistor, is connected in series with this other 3 ohm resistor. Now, you might be asked, can you calculate the total resistance of this portion of the circuit, right? So since these are in series, to calculate total resistance in a series circuit, we simply add the resistance of each resistor. So basically, in our example here, we are having 3 ohm and a 3 ohm resistor. So our total resistance is going to be R1 plus R2, which is 3 ohm plus 3 ohm, which is going to give us a total of 6 ohms. So basically what we do is just adding the numbers, and yeah, we're going to find the total resistance. But then in parallel circuit, um, simple addition will not give us the total resistance. It will give us something else. Simple addition just works when we are having only a series circuit actually. Now, when we have a parallel circuit, we use a formula. So the formula is this one, saying RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus infinity, and all of this you raise it to the power of -1. So that means if you have six resistors in parallel to each other, you're going to have these numbers up to R6. If you have 3 resistors, that means you're going to have 1 up to R3, and then all of it you're going to raise it to the power -1. I think we should do some examples there. Let's start with this one. All right, so here we're having a complete circuit. Here we're having a power source which is connected to these 3 resistors in these resistors are in parallel to each other, right? Now you might be told, can you calculate the total resistance in this circuit? So if you just take, here we have R1, R2 and R3. So if you take 3 ohms plus 2 ohms plus 4 ohms, it will not give you the total resistance according to this circuit, because that's how you calculate if your circuit is a series circuit or if your resistors are connected in series. But then in parallel, that means you're going to use that formula that we're given. So the formula says, according to uh, this circuit, we are having 3 resistors, so we're going to stop at 3. So total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3. All of which are going to raise it to the power -1. So we're going to substitute. Where there's R1, we put the 3 ohms. When there's R2, we put the 2 ohms. And where there's R3, we're going to put the 4 ohms. So total resistance, RT, right, is going to be the sum of this raising to the power -1. When you do this, when you add these 3 fractions, you are supposed to get RT is equal to 13 over 12. That's ohms, right? All of it, you're going to raise it to the -1. So when you are having a fraction that is raised to the -1, it's the same as just taking what is on the board. Just inverting the fraction and then omitting the negative sign. So that means total resistance is the same as 12 over 13 ohms. Now 12 over 13, if you divide that, you're supposed to get RT is equal to 0 0.9 230769 ohms. You can round that up to one decimal place so that it should get the total resistance of this circuit to be 0 0.9 ohms. So that's how you can calculate the total resistance of resistors that are connected in parallel to each other in a circuit. I think we should do a second example. All right, so let's say you have a question that is saying, can you calculate the total resistance of the following circuit? So this is just a portion. It's not a complete circuit as the one we had in example 1. All right, so now if you can see here, we're having two resistors that are connected in parallel, and here we're also having two resistors that are connected in parallel. But then these two resistors and these two resistors, they are connected in series to each other, right? That means these two are going to give us one resistor. If you add this, they are also going to give you one, and this one, and then the other resulting one, they are going to be in series with each other. So you cannot add all of these as if they are all in parallel to each other. So you can name this resistor 1, this is resistor 2, this 3, and this one 4. So what we're going to do is we're going to calculate these ones because they are in parallel. Calculate these ones in parallel separately, and then calculate these ones in parallel separately, and then the resulting ones, we are also going to calculate them whilst using the how you can calculate using the series exactly. Now let's calculate the total resistance of this section. We can call it A, right? So resistance of A. Now that will be 1 over R1 plus 1 over R2. Yeah, you invert that to negative 1. So resistor 1 is 2 ohms, resistor 2 is 3 ohms. So we are having RA is equal to 1 over 2 ohms plus 1 over 3 ohms. Raise that to the negative 1. When you do that, you see that when you add these fractions, these two, you're supposed to get 5 over 6. That is in ohms, right? Raise that to the negative 1. So as I said, when you have a fraction like this and it's raised to the negative 1, what we do is we just invert the fraction. So the total resistance is supposed to be 6 over 5 ohms, and when you divide that, you're supposed to get 1.2 ohms. So that means the total resistance of this circuit is 1.2 ohms. And then what we're remaining to do with is to calculate the total resistance of this section here. So we can call that section B as well. So RB is supposed to be 1 over R3 plus 1 over R4, and raise that to the negative 1. When you do that, it's supposed to get 1 over 4 ohms plus 1 over 4 ohms, raise that to the negative 1. And now when we have a denominator that is common, we just copy it and then add the numbers on top. So when you do that, you're supposed to get the same 4 on bottom, but then when you add 1 plus 1, you're supposed to get 2. So RB is supposed to be 2 over 4. Or you can just say quarter plus quarter, that's supposed to be half, right? So 2 over 4 is the same as half. This is raised to the negative 1. Remember that. And then as we are saying, when a fraction is raised to the negative 1, what we do is we just invert the fraction. So we're supposed to get RB is equal to 4 on top, and then divide that by 2. The units are ohms. When you do that, RB is supposed to give you 2 ohms. Now remember, this section and this section, they will be in series with each other. So how do we calculate resistance of resistors that are in circuit that are in a series circuit? We just simply add. So that means the total resistance is going to be RA plus RB. So RA is 1.2 ohms and RB is 2 ohms. When you add that, the total resistance of a circuit is supposed to be 3.2 ohms. So that's how you are supposed to be calculating your resistors, your resistance, the total resistance in a circuit. Lastly, I'll just leave you with a simple exercise. There are these 4 questions here. We are saying, can you calculate the total resistance in each of the following circuit? So we have A, this one, which is having 3 ohm as resistor 1 and 3 ohm as resistor 2. Here we're having question B, can you calculate the total resistance of this circuit, right? So it's this circuit. And then this is question C, question D. Those are just practice questions. I'm going to give you the solutions to these later, but then you gotta try this on your own. Yeah, thank you for your time. Consider subscribing to the channel and share the video and liking the video for more. See you next time.